Welcome students. In today's video, we will be learning about the graphical method. The graphical method for what? For solving the quadratic inequalities. So without further delay, let's get started on how to solve the quadratic inequalities with the graphical method. The graphical method is not very different from the tabular method. The initial process is almost similar. So in this example, we are asked to write down the range of values of x for which this expression is less than 0. So in order to do that, we first have to take this to be an equation as well, just like how we did in the tabular method. So we will write let x squared minus 16 is equals to 0. And now we know how to solve this equation. We will write it as x plus 4 and x minus 4 is equals to 0. So we get either x plus 4 is equals to 0 or x minus 4 is equals to 0. So from here I get x is equals to minus 4, or from here I get x is equals to 4. And these two values are what? These two values are my critical values that I must mention, because these are not the exact values to my question. These are not the exact answers. Now, just like how we did in the previous method, in the tabular method, we will draw the number line to identify the possible positions of these 2 points. So we will draw the number line to identify the possible positions of these 2 points. So it's either minus 4 or 4. And I know that this divides my number line into 3 regions again. The first region is where x is less than minus 4. The next one is where x is in between minus 4 and 4. And the last one is where x is greater than 4. Now, in the previous method, in the tabular method, we have seen that we draw a table to analyze which one of the regions or which 2 of the regions will be our answer. But in the graphical method, we don't really need to draw the table. Instead, we draw the graph. We draw the graph to analyze which regions will our answer be. So because we have a positive x square in here, right, we can see very evidently that this is a positive x square. We have plus 1x squared. So it's a positive x squared. And we know that for a positive x squared, we have a happy face graph. So we will draw that graph. We will draw the happy face graph in here. So we draw the happy face graph, and I know that this graph cuts at 2 points, minus 4 and 4. Now, these points on the line are for the expression to be equals to 0. This is the point, this line is where our expression is equals to 0. This line is where our expression, that whatever expression is given to us, above the line, it's greater than 0, and below the line, we have less than 0. Now, if we take a look at the question demanded us to find the range where x squared minus 16, the expression is less than 0. So less than 0 would mean that we have to look below the line. So less than 0 would mean we have to look below the line. Below the line is this region. So as we have seen that our number line is dividing this, is being divided into 3 regions. We have seen that the 2 points divide our number line into 3 regions, and we can see that the graph that we have is in this region. Negative 4 is less than x, which is less than 4. So we can say that our answer is negative 4 is less than x, which is less than 4. This is our answer. Let's try to take a look at another example to enhance our understanding. This is another example that we have. So we know that we have to first solve this expression by taking this to be equals to 0 in order to find out the inequality. So we will write it as let 10x minus x squared minus 25 is equals to 0. So when we write this out, we know that we have to solve this by the quadratic inequality. So we will solve it using the quadratic formula. So for the formula, we have to rearrange it and write it as this is equals to 0. So my value of A is negative 1. The value of B is 10. The value of C is negative 25. So my values for x, the critical values would be minus b plus minus root over b square minus 4ac divided by 2a. And from here, the values that I get are repeated values. I get 5 and 5 again. So I have only one value as my critical value. Now what is my next task? My next task is to draw the number line to see what regions do I get. So if I draw the number line, my regions are either x is less than 5 or x is more than 5. Because I don't have any equal to sign in here, so I don't have to consider the point x is equals to 5 in here. Now I know that I have to draw the graph in my graphical approach. After I draw the number line, I will draw the graph. Now for the graph, I see that I have a negative x square graph in here. So for a negative x square graph, we know that we have a sad face to draw. So we will apply that sad face in here. But we have only one point of intersection with the axis. So our sad face will be like this. I will have 5 in here. So my next task is to identify the regions on this line. I have this equation is equals to 0, 10x minus x squared minus 25 is equals to 0 on the line. So on the line, I have 10x minus 25, 10x minus x squared minus 25 is equals to 0 over the line. I have 10x minus x squared minus 25 more than 0, and under the line I will have 10x minus x squared minus 25 less than 0. If I look at the question asks me to find the inequality, to solve this inequality for less than 0. So we have to shade below the axis. So if we look below the axis, we have this region. So my entire graph is below the axis. Now I know that this 0.5 is dividing my region into 2 points. What are those two parts that my region is being divided into? One is x is less than 5, x is less than 5 for this part, and for this part I have x is more than 5. So this is my answer. If it was less than equals to, then I would have considered this line also and taken x is equals to 5 into consideration. But because it doesn't say anything about the equal to sign in the question, so these two are my answers. X is less than 5 and x is more than 5. Let's try to take a look at another example that we have in here. Here again, we have this expression given to us. So we know that in order to solve this inequality, we have to first take it as an equation. So we will write let x squared minus 6 is equals to 5 by 2x. So if we rearrange it in order to solve, we will get x squared minus 5 by 2x minus 6 is equals to 0. So my value of a is 1, b is negative 5 over 2, and c is negative 6. I know that if I am using the quadratic formula, this negative 5 over 2 or any kind of fraction is not a problem for us. We can use it in the formula directly. We can substitute it in formula directly. So we will get x is equals to minus b plus minus root over b squared minus 4ac divided by 2a, and the answers that I get are 4 and negative 3 by 2. And I call these my critical values. Then what do? I will divide the region in using my number line. So I have drawn the number line, and I know these two values divide my number line into two parts. I have negative 3 over 2 in here and 4 over here. So on the left side of minus 3 by 2, I will have x is less than minus 3 by 2. Then in between these two, I will have minus 3 by 2 is less than x, which is less than 4. And on the right side of 4, I will have x is more than 4. Now, if I want to draw the graph, I see that I have positive x squared. So I know for positive x squared, I am going to have a happy face curve. So I will draw that graph in here. So I draw the axis and I draw the graph. So I get negative 3 by 2 in this point and 4 in this point. Now I know that on this line, I have x squared minus 6 is equals to 5 by 2x. Over this line, I have x squared minus 6 greater than 5 by 2x. And under this line, I have x squared minus 6 less than 5 by 2x. So now in the question, I had greater than equals to. So greater than equals to would mean what? For greater than equals to, it would mean for equals to, first of all, I have to consider this line. Any point on this line I have to consider. And for greater than, I will have to consider above the axis. All the points that I have above the axis will be my answer. So I know that my number line has been divided into 3 parts, with these 2 points also into consideration now, because I have to consider the equal to sign. So for the equals to sign, I have these points x is equals to minus 3 by 2 into consideration and x is equals to 4 into consideration. Then for greater than, I have this region, these two regions for greater than, because my graph is in this side and my graph is on this side. So in this side, I have x is less than minus 3 by 2, and on the other side, I have x is more than 4. So if I combine to write my final answer, I can write that x is less than equals to negative 3 over 2, because I can see that x is equals to negative 3 by 2, and then it is also less than negative 3 by 2. So it is less than equals to negative 3 by 2. And in the same way, x is equals to 4 and x is also greater than 4. So I can write x is greater than equals to 4. So this is my final answer. If we review whatever we have done, we can see that we first, for any quadratic inequality, assume it to be an equation and then solve it to find out the critical values. Then after we find out the critical values, we can use the number line to identify or name the regions that the critical values divide the points into. So all our points are categorized into 3 regions, where one is x is less than negative 3 by 2, one is negative 3 by 2 to 4, and the other one is x is more than 4. Then because we have a positive x square graph in here, because of this positive x square graph, we know that positive x square graph is always the happy phase graph. So we drew the happy phase graph. And now we know that for the graph, any point on this line is equals to, is an equation, represents an equation for above the line. We have the x square minus 6 greater than 5 by 2x. Why? Because when we solved, we wrote the equation like this, where we had x square minus 6 minus 5 by 2x. We can write greater than 0. So if 5 by 2x stays on the other side or stays on the left hand side, it doesn't make any difference. We can write that this is greater than 0, and then for below the axis, for any points below the axis, we can write x square minus 6 minus 5 by 2x, which is less than 0. We know all points under the axis. If we draw the y-axis, we can see that all points below the 0 represent negative y, and all points above represent positive y. So above the axis, we have positive, and below the axis, we have negative numbers. Now, we have to consider for greater than equals to. That was given in the question, greater than equals to. So for equals to mean that we have to consider any point on the line. So on the line means these 2 points, x is equals to minus 3 by 2 and x is equals to 4. And above the line, where we can see the graph, that the graph is in these 2 regions. The graph is here, as we can see that the graph is here, where x is over 4 in this region, and the graph is here where x is less than negative 3 by 2. So we have written those 2 regions in here. Now we can see, if we want to combine these 2 answers, we will get x is less than minus 3 by 2, and for the other one, we have x is over, greater than, or more than 4. X is over 4 in here, and we have x is equals to 4. So we combine these 2 to get x is greater than equals to 4. That's how we can solve equations using the graphical method. So that is it on solving equations using the graphical method, inequalities using the graphical method. And in the next one, we will see how to combine 2 linear equations, 2 linear inequalities into one.